In December 1986, a cargo plane operated by the China National Aviation Corporation touched down at an airfield outside Urumqi in the Xinjiang Uyghur Autonomous Region, carrying 11 horses. The animals had been flown in stages from zoos in East Germany, the United States, and the United Kingdom. They had spent the previous 72 hours in transport crates. None of them had ever walked on land that was not behind a fence. Within 48 hours of arrival, the 11 horses were transferred by truck to a fenced acclimatization facility in the Yungar Basin, a 380,000 square kilometer depression of dead soil and shifting sand in the far north of Xinjiang. Local pastoralists had stopped calling the region land. The Chinese name for the area translates approximately as the place where nothing grows. Winter temperatures in the basin routinely fell below -40 degrees Celsius. The nearest reliable surface water was 15 kilometers from the release site and frozen solid under 4 inches of ice for 5 months of the year. The Chinese government had spent the equivalent of several $1,000,000 to transport these specific 11 horses to this specific dead ground. A BBC documentary crew flew in from London to film what they expected to be the project's collapse. The crew left after 2 days. They had seen enough to write the story. The horses, in the producer's notes for the cancelled segment, were not going to survive the first winter. What those 11 horses did in the 4 decades that followed has rewritten the standard scientific assumptions about how degraded ecosystems recover, what extinction actually costs, and what a single animal species is capable of doing to a landscape when the right species is returned to the right place. It is also the story of how China, after spending $47 billion on a tree planting program that was making its desert problem worse, accidentally discovered that the solution to one of the largest environmental crises in modern history had been walking through the steppes of Central Asia for 40,000 years before humans drove it to extinction. The horse the world almost lost. The animal at the center of this story is Equus ferus przewalski, the Przewalski's horse. It is the last truly wild horse species on Earth. Every other horse alive today, every Arabian, every thoroughbred, every Mustang, and every working draft horse descends from a domestication event that began in the western Eurasian steppe approximately 6,000 years ago. The Przewalski's horse was never part of that event. It has never been broken. It has never been ridden. It carries 66 chromosomes instead of the 64 found in every domestic horse, a genetic separation that places it on a slightly different evolutionary branch from the rest of its family. The species is named for Nikolai Przewalski, the Russian explorer who brought the first specimens to European scientific attention in 1881. By the time it was formally described in the scientific literature, the species was already in steep decline across its range in Mongolia, China, and the southern Russian steppe. Between 1899 and 1903, a small number of foals were captured by Russian and German collectors working on commission for European zoos. Those foals, 12 to 14 individuals depending on which records are consulted, became the genetic foundation of every Przewalski's horse alive today. The wild population continued to decline through the first half of the 20th century. The last confirmed sighting of a wild Przewalski's horse in its native range was recorded by a Soviet geological survey team in the Dzungarian Gobi in 1969. A few hoof prints in dried mud. A handful of tan hairs caught in a thorn bush. After that, the species was extinct in the wild. The captive population, descended from the original 12 to 14 captured foals, hit its lowest point after the Second World War. By 1945, 31 Przewalski's horses existed worldwide, only 9 of which were capable of reproduction. The species survived a multi-year window in which the entire global population existed in 2 zoos, the Munich Zoo and the Prague Zoo. Every Przewalski's horse alive today carries a genetic bottleneck from that period. The species came within a small handful of breeding individuals of disappearing entirely. By the early 1980s, decades of careful zoo breeding had brought the global population back up to approximately 900 animals. Every one of them was in captivity. The question of whether the species could ever be returned to a wild existence remained, in the standing assessment of the international conservation community, an open and unanswered one. The basin that died. The Yungar Basin had not always been a dead landscape. Paleoclimatological evidence from sediment cores indicates that for at least 10,000 years after the last glacial maximum, the region supported a productive grassland ecosystem with substantial populations of wild ungulates, including the local Przewalski's horse population. The ecosystem had evolved around those animals. The grasses, the soil microbiome, the seasonal precipitation patterns, the predator populations, the entire functional architecture of the basin had developed in continuous coevolution with the hoofed animals that had walked through it for millennia. When the Przewalski's horses disappeared from the basin in 1969, the rest of the system began to fail. The mechanism of failure was not what conservation biologists at the time expected. The standard assumption was that the absence of grazing pressure would allow vegetation to recover. What actually happened was the opposite. Without the constant percussion of hoof impact on the soil surface, the basin's already thin topsoil hardened into a calcified crust that researchers monitoring the situation began to describe as biological concrete. The 4 to 6 inches of annual precipitation that fell on the region could no longer infiltrate the surface. Water sheeted across the hardened ground and evaporated within hours of falling. Seeds could not push through the crust to germinate. Soil nitrogen levels collapsed. By 1974, samples taken from the Central Basin and analyzed at the Xinjiang Institute of Ecology and Geography were producing biological activity readings comparable to lunar regolith. The sand and silt grains were still present. The basin had simply gone biologically dead. The dead basin then began to move. Satellite imagery from the early 1980s documented the Gobi Desert expanding southward at approximately 70 kilometers per decade, swallowing grassland, displacing pastoral communities, and burying transportation infrastructure across northern China. In March 1983, a single dust event originating in the Yungar Basin deposited an estimated 43,000 tons of topsoil on Beijing, more than 1,000 miles to the east, in less than 72 hours. Hospitals in the capital reported a 300% increase in respiratory emergency admissions during the event. The Chinese government's standing modeling at the time projected that Beijing itself would become borderline uninhabitable by 2050 if the desertification rate continued. The official response, the 3 North Shelter Forest Program launched in 1978 and known internationally as the Green Great Wall, involved the planting of an eventual 66 billion trees across a 4,500-kilometer corridor along the northern frontier. The program cost approximately $47 billion over its first 3 decades. It was, by the mid-1980s, visibly failing in the most degraded sections of the basin. The trees required more groundwater than the desert could supply. Water tables that had been stable for centuries dropped by 12 meters in some monitored regions. Trees planted in neat rows began dying from the bottom up as their roots failed to reach the falling water tables. Whole villages had to be relocated when their wells ran dry. By 1985, agricultural productivity in Xinjiang had fallen 34% from baseline. The standing engineering response to the desertification crisis was not working, and it was into that policy vacuum that Yang Jianming, a Chinese ecologist working at the Xinjiang Institute, walked into a government meeting and proposed something that the official record indicates was received with substantial skepticism. He proposed bringing back the wild horse. The pitch. Yang's argument, as presented to the relevant Chinese state planning bodies in 1985 and documented in the Institute's subsequent publications, did not rest on conservation grounds. He was not arguing that the Przewalski's horse should be saved because it was rare. He was arguing that the Yungar Basin could not be saved without it. The argument had three components. The first concerned soil mechanics. Adult Przewalski's horses weigh between 600 and 800 pounds. The impact of a hoof strike on the basin's hardened crust delivers approximately 800 pounds of pressure per square inch, comparable to the impact pressure of light industrial machinery. Yang's modeling indicated that this impact, applied repeatedly across the basin by a sufficient number of animals, would fragment the calcified surface crust and restore the infiltration capacity that the soil had lost. Crucially, the horses would apply the impact selectively. Unlike mechanical aeration, which damages established vegetation, horses walk around live plants and concentrate their impact on bare ground and dead vegetation. The instrument was both more forceful than mechanical alternatives and more discriminating. The second component concerned movement patterns. GPS tracking studies of wild equids from other Central Asian populations had shown that the animals move in what mathematicians describe as fractal patterns, with intense grazing concentrated in small areas, abrupt relocations of several kilometers, and looping returns to previous grazing sites days or weeks later. The pattern produces what landscape ecologists call a disturbance mosaic, a patchwork of intensely grazed, lightly grazed, and ungrazed areas that supports substantially higher species diversity than uniformly managed grassland. Yang's modeling suggested that even a small herd would produce a disturbance mosaic across a large fraction of the basin within the first decade. The third component concerned seed dispersal. Analysis of equid dung from existing wild populations had documented viable seeds from more than 20 distinct plant species per sample, with germination rates substantially improved by passage through the equid digestive tract. The acids and physical abrasion of the gut break the seed dormancy that keeps grassland seeds locked up for years in undisturbed soil. The published figures Yang cited indicated approximately 7.4 viable seedlings per gram of dung, roughly double the dispersal rate of cattle and 8 times the rate of sheep. A herd of horses moving 15 kilometers per day across the basin would effectively function as a distributed seed delivery system, planting hundreds of thousands of pre-fertilized, pre-scarified seed packets across the landscape every season. The proposal was approved in 1985. The first 11 horses arrived in late 1986. The first winter. The horses spent their first months at the Jimsar acclimatization facility, which had been constructed specifically for the project at the southern edge of the basin. Within weeks of arrival, parasitological surveys identified botfly infestations in 100% of the herd. The larvae burrowed into the horses' stomach linings, producing painful lesions that compromised digestion at exactly the period when the animals needed maximum caloric intake to develop the body fat reserves for winter. The first winter arrived in November 1987. Temperatures in the basin that year reached -42 degrees Fahrenheit. The horses, which had been raised in climate-controlled European zoo facilities, were exposed for the first time in their lives to weather that no domestic horse breed has been documented to survive without shelter. Their distinctive standing manes froze into ice ridges, thick enough that some animals could not lift their heads. Snow accumulation buried the basin's remaining vegetation under 3 feet of powder. Yang's protocol, which the international monitoring teams initially considered cruel, was that the staff at Jimsar were forbidden to intervene unless the entire herd was at immediate risk of collapse. Individual animals could die. The project was designed to test whether the species could survive without human management. If it could not, no amount of supplemental feeding would change the outcome over the long term. 7 of the 11 horses developed severe frostbite during the first winter. 2 pregnant mares miscarried in the cold. International conservation journals began preparing what the editors expected would be retrospectives on the project's failure. Yang himself, in interviews he gave decades later, acknowledged that he was preparing for the worst. The animals did something nobody had predicted. The dominant stallion began breaking ice on frozen pools with his hooves. a behavior that had never been documented in captive Przewalski's horses in any zoo facility. The mares began arranging themselves around their foals during storms, forming protective windbreaks with their own bodies and rotating positions as individual animals became too cold to remain in the windward position. The herd as a whole began digging through snow with sweeping motions of their forelegs to expose buried grass. They began reading the wind, choosing slopes that had been swept clear by prevailing winds rather than slopes where snow had accumulated. These behaviors were not learned. There was no captive-born adult in the herd who could have demonstrated them. They emerged spontaneously in animals whose immediate ancestors had spent 3 to 4 generations in European zoos eating hay from buckets. The behaviors were, in the working interpretation that Yang's team eventually arrived at, genetically encoded survival programs that had been preserved across the bottleneck and reactivated under environmental pressure. The basin had not extinguished the wild horse. It had woken it up. The basin wakes up. The second year of the project produced the first measurable changes in the basin's ecology. Compensatory growth, the phenomenon in which grasses respond to grazing pressure by producing more biomass than they would otherwise, increased above-ground plant production in grazed zones by 43% compared to ungrazed control plots. The horses were not depleting the vegetation. They were stimulating it. Soil moisture retention in the grazed zones increased by 23% over baseline within the first full year. The mechanism was the hoof impact Yang had predicted. The calcified surface crust was fragmenting under the percussion of approximately 10,000 hoof strikes per hectare per year, opening tens of thousands of small infiltration points that allowed precipitation to penetrate the soil instead of evaporating off the hardpan. Each hoofprint functioned as a miniature reservoir, capturing rainfall that the basin had been unable to absorb for 2 decades. The third year produced a 37% surge in soil nitrogen levels. The mechanism was the horse manure, which was reintroducing not only the seeds Yang had predicted, but the gut microbiome of the species itself. The basin's soil bacterial community, which had been depauperate since the original Przewalski's horse population disappeared in 1969, began to re-establish itself from the inoculum the new herd was depositing across the landscape. Botanists working with the project began documenting plant species that had not been recorded in the basin for nearly 2 decades. 22 distinct species reappeared in the first 3 years of the project. Their seeds had been in the soil the entire time, dormant, waiting for the surface conditions that would permit germination. The basin had not been dead. It had been waiting for its keystone species to come back and unlock it. The herd survived the second winter, then the third, then the fourth. By 1995, the population at Jimsar had grown enough that Yang's team began planning the next phase of the project, which involved removing the perimeter fences entirely. Day 8. In August 2001, after 15 years of acclimatization, captive breeding, and behavioral monitoring, 27 Przewalski's horses were selected for full release into the Kalameli Nature Reserve, a 40,000 square kilometer area in the northern Djungar. The release involved no perimeter fencing, no supplemental feeding, and no permitted human intervention. The horses were fitted with GPS collars and released into terrain that had not seen their species for 32 years. For the first week of the release, the horses remained within 500 meters of the release point. They grazed nervously. They circled back toward the empty pens. The monitoring team, watching the GPS data from a station several kilometers away, began to express concern that the horses had lost the dispersal instinct that the project depended on. On the morning of day 8, the dominant stallion of the lead harem, an animal the keepers had named Hong, began walking. He walked in a straight line due north. His harem followed in formation. The GPS signal moved 5 kilometers from the release point, then 10, then 15. The monitoring team began making phone calls. Hong stopped at a spring-fed pool roughly 30 kilometers north of the release point. The pool did not appear on any of the project's survey maps. No member of Hong's bloodline had walked the route to that water source in any lifetime that the project could trace. The team's working hypothesis afterward was that the horse had located the water by some combination of olfactory and atmospheric cues that the human survey team had not detected and did not understand. The standing observation in the field notes, written by Yang himself, was that the horse had simply known where to go. Within a month of release, the horses had partitioned the reserve into stable territories. The stallions were marking boundaries with strategically placed dung piles on raised ground, a behavior consistent with the territorial signaling observed in other wild equid populations. Foaling rates in the first wild-born generation reached 87%, substantially higher than the survival rate for captive-bred foals in zoo conditions. The foals born in the reserve were distinguishing between 23 different plant species by smell, responding instantly to the shadow of a steppe eagle by freezing in place, and developing winter coats noticeably thicker than the coats of their captive-born parents. The basin itself was changing on a scale visible from orbit. Satellite imagery taken between 2001 and 2005 showed green patches expanding outward from the horse territories in patterns that the analysts at the China Earth Observation Center began describing as ecological wake patterns. The basin's water table, which had been dropping by 3 centimeters annually since 1970, stabilized in 2003. By 2007, it had begun to rise, the number that broke the model. By the late 2010s, the data the project had produced was forcing a serious revision of the standing scientific assumptions about Chinese desertification policy. The 3 North Shelter Forest program had cost $47 billion and had, in the basin and in several other monitored zones, actively worsened the underlying water table problem. The horses, costing a fraction of 1% of the tree planting budget, were reversing it. The mechanism was straightforward enough that the ecological economists who studied the project published it in language that policy planners could understand. Trees consume substantial groundwater. Grasslands consume approximately 90% less groundwater than equivalent forest cover. A single Przewalski's horse, through the combination of soil aeration, seed dispersal, microbial inoculation, and grazing-induced compensatory growth, was improving water retention across approximately 50 hectares of basin per year. The economists working at the Xinjiang Institute of Ecology and Geography ran the full calculation. Soil restoration value per horse per year, approximately $12,000. Seed dispersal value, approximately $8,000. Water retention value, approximately $15,000. Carbon sequestration value, approximately $7,000, biodiversity support value, approximately $5,000. Total ecological services valuation per horse per year, approximately $47,000. By 2023, the herd descended from those original 11 horses had reached 534 animals. They were effectively managing 26,700 hectares of restored landscape. The total annual ecological services value generated by the program had reached approximately $25 million, a figure that did not include tourism revenue, scientific research value, or carbon offset markets. Among the horses in the reserve were dozens of Hong's descendants, now spread across multiple harems of their own. The basin that had been expanding into the Chinese capital was retreating, withdrawing at approximately 47 hectares per year in the zones the horses occupied. 20 plant species that had not grown in the basin in living memory were established in stable populations. Insect species absent for 15 years had returned in numbers measured in millions. Steppe eagles, foxes, and the occasional gray wolf had reappeared on the camera traps. Dung beetles, which had vanished with the horses in 1969, returned with them in 2001 and were accelerating the recovery loop by burying the manure that the soil microbiome required. The Mongolia release at Hustai National Park, modeled on the Chinese project, had reached 490 animals by 2023. Kazakhstan launched its Golden Steppe project in 2024. Russia is studying the Chinese data. The Chinese government's current plan calls for expanding the Kalamyli Reserve by an additional 350,000 square kilometers with a target population of 2,500 wild horses by 2040. The associated modeling projects that a population of that size would restore more than 100,000 hectares of degraded land, sequester 43,000 tons of carbon annually, and support more than 300 species of plants and animals that currently exist nowhere else in the Chinese ecosystem. What it means. The Yungar Basin will, if the modeling is correct, become the first major desert in modern human history reversed not by engineering, not by irrigation, not by tree planting, and not by human design, but by the restoration of a single species of animal that humans had previously driven to extinction in the same landscape. The 11 horses that stepped off the cargo plane in 1986 were not, in the working interpretation the project has produced after 4 decades of data, an endangered species being preserved at considerable expense. They were a biological technology refined by evolution across hundreds of thousands of years, capable of designing and maintaining an entire grassland ecosystem at a level of complexity that no human engineering project has been able to match at any cost. The implication of the project, the part that has begun to circulate seriously in conservation policy circles outside China, is that a substantial fraction of the environmental crises currently being addressed by expensive top-down engineering interventions may be more efficiently and more durably addressed by the restoration of the ecosystem humans drove out of the landscapes in question: the American bison that maintain the prairie, the gray wolves that maintain the boreal forest, the forest elephants that maintain the savanna, the beavers that maintain the river systems of temperate North America. Each of these species, where it has been reintroduced, has produced ecological recovery on timescales and at scales that no human management program has matched. The framework that the Yungar Basin Project has produced is uncomfortable for the institutional structures that have managed environmental policy for the past half-century. The framework suggests that the question is not how to engineer recovery from the top down. The question is which species humans removed from the landscape and whether they are still available to be put back. The technology to repair the damage in many cases is not something human engineers need to invent. It is something humans need to remember they extinguished and locate in whatever surviving populations remain in zoos and captive breeding programs and small remnant wild populations scattered across the planet. The basin in northern Xinjiang that was expected to make Beijing uninhabitable by 2050 is now slowly absorbing dust storms instead of generating them. The water table that was dropping for 30 years is rising. The grass is growing back. The eagles are nesting again. None of this required new technology. It required 11 horses, a 40-year commitment, and the willingness of a small group of ecologists in 1985 to walk into a state planning meeting and propose, against the unanimous opinion of every engineering expert in the room, that the desert be allowed to remember what it had been before the species that maintained it was driven out. The horses did the rest.